Can you close your eyes and think of a famous building that comes to your mind? What building can you think of? You might come up with 63 Hanwha Building, Lotte Tower, or Burj Khalifa. I guess many of you would think of vertically high skyscrapers. Like these, you might be familiar with buildings famous for its height. However, what about buildings known for its tilt? What kind of buildings can you think of that are famous for its lean? I bet the Tower of Pisa would be the first and almost only building that comes by. But would you believe it if I tell you that there is a building that is 5 times more tilted than the Tower of Pisa? It is the Capitol Gate Tower. It has its name listed in the Guinness World Record for being the farthest leaning man-made building on this planet, having the leaning angle of 18 degrees. As you can see, this Capitol Gates Tower, which is inclined to one side, twists as it goes up, has an appearance slightly off the original skyscraper. Then how and why did this uniquely shaped tower get constructed? And why was it specifically built in Abu Dhabi? To understand the reason, we need to first know about the historical background of Abu Dhabi and its culture of the Sultan. UAE, which has the 6th largest oil reserves in the world, consists of 7 independent city-states. In these 7 states, the larger the area, the more oils were reserved, which meant it had strong economic power. Among these, Abu Dhabi was the largest of the states, so also the richest. However, Dubai, which was 1/15 of the area of Abu Dhabi, was known to be more technologically advanced than Abu Dhabi, which made Abu Dhabi feel a strong sense of rivalry, and there was natural tension between the two. Starting from the early 2000s, Dubai began to construct high and massive size architectures like Burj Khalifa and Burj Al Arab. Sheikh Sultan from Abu Dhabi, who was very rich, had studied architecture in his old days and naturally had interest in the architecture industry. Watching the high landmarks of Dubai getting constructed, he had a desire to construct such a landmark in Abu Dhabi too. Having a strong sense of rivalry, he wanted more than just a high and massive building. He wanted something that could be told architecturally impossible. Receiving this request, it was now the designer's job to come up with an extraordinary design that would satisfy the Sultan. The surrounding scenery helped them with their job. The designers got inspired by the beautiful seaside and dunes of Abu Dhabi. Getting ideas from the two elements, the rolling waves and the sand's spiraled shape, they wanted to design a building with a tilted and twisted shape that would go well with the beautiful scenery of Abu Dhabi. Also, the curved canopy, known as the splash, creates a wave-like effect given the building is close to the water, with Abu Dhabi's heritage being near the sea. With the lean, twist, and the splash, the designers had designed this curvaceous shape of the Capitol Gate Tower, and this would be able to be perfectly connected physically and visually with its site. However, this complicated piece of design needed many special measures taken to sustain itself. The structural engineers had to think of a way to prevent the leaning building from toppling over. They came up with 2 important installations. First, to realize the leaning shape, the designers devised a method to install biased slabs, making longer spans while going up. But engineers knew if they installed the slabs like that, a vertical core would not be able to sustain the overhang and moment, as well as its vertical loads. So, the engineers decided to make a new core named pre-cambered core, which was bended to the opposite direction of the leaning part. As constructors added the slabs to the upper levels, the weight of the leaning parts would pull the core back into a vertically straight state. The whole core would be in tension, and that would be able to give it immense strength. Secondly, they wanted some other method to resist the lean's load without spoiling the beauty of the tower. Inspired by the thin layers of eggshells, the structural engineers decided to use a diagrid acting as a uniform net that forces were evenly distributed. Based on the truss structure, the triangular unit can not only resist vertical loads like the core, but also transfers the subjected lateral load to the member below. Now, it was the constructor's job to realize the designer's request and the structural engineer's theoretical solution and make this impossible building come true. In the realizing step, before constructing the pre-cambered core and diagrid, constructors had to make a unique foundation that could resist load, which was not evenly distributed on the ground, and the overhang caused by its leaning design. Also, Capitol Gate Tower's site, which is close to the shore, had a weak foundation. So, it was necessary to use pile foundation. They used 203 friction piles on the front side where the weight is going down into the ground due to the inclination, and 287 end-bearing piles runs to a depth of 30 meters to the bedrock, anchored tightly to the soil. Thanks to this foundation process, Capitol Gate Tower was one step closer in resisting the massive amount of overhang made by the leaning design. Now, the foundation is complete. To realize the lean and twisting form, other groundbreaking construction methods had to be used, which led to a harder process for constructors. On construction site, to make the pre-cambered core, they had to prevent cracks generating due to the overhang. So, the constructors installed pre-stressed tendons to the core, which would counteract the pulling force created by the massive overhang, stopping the concrete from tearing apart. As the tendons were 20 meters long, heavy, and were bended irregularly, it was impossible to pick up the end point of the tendon and place the opposite point exactly to the duct with handwork. That is why in this process, it was necessary to bring in the crane to the construction site. The team used the steel tendon's weight to force it through a duct already cast through the core. Once the tendon got in position, the team would lock off both ends, ready to tension its individual strands once again. This method had not been used before, but it was very effective in increasing the strength of the core. They made 4 meters of core in a week and repeated the same work. But this repetitive method wasn't used for the whole units of the core at once. Among the ways to complete a fixed quantity in a timely manner, there may be a method of adding more manpower or extending the work time. But this wouldn't be the optimal solution. The engineers divided the core into 3 sections. The workers of form work, rebar work, and concrete pouring work would not interfere with each other. As a result, the process is constantly circulating and can proceed at the same time. So even a small number of workers could perform fast construction. Eventually, Capitol Gate Tower's core could be realized with a new technology named pre-cambered core and post-tension tendons. Also, appropriate usage of existing methods like internal crane and auto climbing system. Now, to realize the twist of Capitol Gate Tower. Unlike the normal uniform diagrid, it was indispensable to use all different diagrids with its unique geometric shape. Besides, it would be extremely difficult to connect these unique shapes into one whole mesh. If the diagrid is not assembled with millimeter accuracy, the mesh will be unable to channel the loads, and the structure would become meaningless. With BIM and Tekla 3D model, they precisely predicted each unique cruciform's detailed length, curvature, and different form of nodes to connect them. With these, they were able to make each 720 designed cruciforms that neither one was the same. The engineers used an old-school method, chalk, to mark and calculate exact angles. It might look unsophisticated that they drew plans on the ground with rulers and protractor, but it was highly accurate, ensuring all the members. After that, they could cut and connect each members according to the chalk line drawn by the constructors at specific angles with high accuracy. What was left for them was to accurately assemble the unique forms to create a uniform net for the load. When they started to assemble those, three-dimensional GPS system was used. The global 3D coordinates taken from the Tekla model were utilized for erecting the diagrid assemblies at their exact position. When each cruciform was lifted to the precise position, a team of 240 steel fabricators matched the opposite side of the endpoint on hand and assembled the diagrid with nodes and welded all three together. By this, the constructors could proceed the task accurately. The diagrid was finished. What was left for them was to assemble them with glass claddings and finish the facade. To realize the twisted form, they had to attach the all different shaped diamond units. In the process, they needed the millimeter accuracy, but there was a different problem from the diagrid. We have mentioned before that the pre-cambered core straightens as it grows, so it means that the skyscraper will not stop moving until after completion. More than that, with the harsh climate conditions of Abu Dhabi, the facade had to accommodate the additional movement due to heat expansion and strong wind. Keeping these in consideration, the construction team had to find reasonable solutions to realize this complex facade with glass panels. Capital gates, each large panel, was fixed in just 2 places at each side. A special sliding joint was developed to locate at the top and bottom of each panel, allowing room for additional vertical building movement. As the diamonds were stacked over one another, starting from the bottom, the remaining unfixed 2 points would be fixed by attaching the next diamond, and this process would repeat. By this, it would give room for extra movement during the construction before all points would be totally fixed. They also used a special system in connecting the diamonds too. Diamond connects to each other with a 2-layer bespoke seal. Flexible spongy seal allows the facilitation of movement. With this, the pre-cambered core and diagrid was able to successfully realize the leaning, twisted form of Capitol Gate Tower. Finally, they had realized the leaning appearance. But this was not enough to satisfy Sheikh Sultan's request to make Capitol Gate Tower an iconic building. The designers came up with a new demand for additional structures, pushing the design to the extreme. They wanted to build an infinity pool and a restaurant hanging 100 meters above the ground, without any visual support. To accomplish this, the structural engineers brought on hidden structures and the principle of the insects that can walk on water. However, it was still impossible to keep the additional structures to sustain this massive and heavy cantilever completely hidden. The designers came up with a great solution, and this is one of the most noticeable design features of Capitol Gate Tower. It is the splash. It's a layer of woven metallic mesh stretched over a metal frame, stretching as an extension of the cantilever. This is not only an excellent design element, but it would shade the tower from the hot sun. However, installing this additional structure would give immense load to the already massive weight. It was necessary to put it at an optimal place. When the engineers who managed the load of the building received the demand of cantilever, they had to suggest an idea to solve the already existing massive overhang and also stabilize the extra structure. The engineers suggested counteracting by installing cantilever on the opposite side of the lean to reduce the immense overhang. But even with the cantilever, it was not enough to reduce the overhang. In the upper part, they had to find a solution to sustain the building's increasing floor weight and overhang due to the lean. Engineers and designers consulted and decided to diet the leaning upper load that caused the overhang fundamentally. This was when the architects came up with a clever solution. It was bringing in an internal atrium inside the upper floors of the building. With the void getting larger as it goes up, it has the shape of a funnel. It helped the tower sustain the lean, preventing it to topple over. However, with this empty space, the upper load of the building would become unpredictable, and punching too much pressure to the core, it might collapse. So, they mirrored the external diagrid to make an internal diagrid. With this, it could successfully gather the loads and disperse them back into the adjacent diagrid and to the whole part of the building, thereby reducing the burden. The additional structures, requested as a design factor for the iconic building at first, were actually structurally helpful and energy efficient. With these, they had almost finished constructing the iconic building. With the efforts of engineers and constructors, the additional requests of the designers were almost finished. However, 6 months before completion, when everyone thought that the construction was almost done, Sheikh Sultan made an urgent request that a helipad be built on the roof of the building. When the contractors first heard about this, they thought it was just a joke. But when Sheikh Sultan called them directly, the contractors had to think about putting a helipad at the highest point in Abu Dhabi. This request seemed easy at first, but it posed serious problem. That was wind shear tipping the whole helicopter on its side. Wind shear refers to a phenomenon that occurs in the process of filling air in an empty space due to a difference in wind speed. The rapid change of wind speed by wind shear often affects the blades of helicopters about to land and causes accidents. So, they had to predict and prepare for wind shear that could occur on the roof in a short time. The best way in this situation was to make a model and put it in a wind tunnel. A scaled-down Capitol Gate has entered a high-tech wind tunnel in London. In this experiment, the contractors get the most undesirable result. It happened that the wind shear situation was worse than expected. Wind shear created an air curtain flow over the top of the building. Spiraling turbulent flow separating the surface was created. This was not the only problem the wind tunnel test showed. The winds affecting the helipad created large suction force. This force tried to blow the helipad off the roof of the building. In order to make this helipad safe, the builders decided to lower the position of the helipad 2 meters. Because the tip of Capitol Gate Tower's top leaning side could protect the helipad and the helicopter's course from strong shear wind. Lowering the helipad was not an optimal design. However, after wind tunnel tests were conducted, they could find out that they had successfully reduced the wind shear threat. This seemingly impossible building that the Sultan wanted was realized with lots of people's efforts. The designer's endless pursuit for the gorgeous building, engineers' massive sense of responsibility for safety, and the constructor's willpower of never giving up realizing it. Without these three parts harmonious altogether, the drawing's result would not have been able to come to life before our eyes. Studying this building, we were able to learn the overall construction methods and principles that were even difficult for experienced experts. In the start of this construction engineering class, our first impression of the Capitol Gate Tower was that its appearance was simply beautiful. But after 12 weeks of studying, we were able to trace the efforts of constructors and their engineering methods and studies that were reflected in the building. And this was a very educational opportunity for us. Thank you all for listening to our presentation with us this semester.